you may continue with it. You may continue with your presentation.
Okay, let me just try to explain the remaining formulas so that maybe by 12 we can do go through the examples or the exercises, right?
Yes.
Okay,
I want to mute my mic.
as I was saying that on the formulas, nah, this one is the formula which is going to be applied when you are going to use the when the population standard deviation is what is known. Okay, when the population standard deviation is going to be known, we're going to use this formula: the x bar plus or minus the z theta divided by 2 multiplied by the sigma divided by square root of n. It is the same of this, just that the only difference is that this one is not expanded, and the second one, if you can check, it's written in a proper way because we are talking about the intervals, right? So meaning at the end we should have an answer which is written in intervals. Okay, so plus or minus, ne? Plus or minus, we're going to get an answer which is going to be in form of an interval, just like when you are calculating a quadratic equation. At the end of your answer you're presenting it in either negative and also positive. Okay, so in this case also we're going to have negative this side and positive this side because of this plus or minus. I hope we're clear on this one, on this formula, right? So now we're going to check at the formula when the population standard deviation is unknown. This one, it is unknown. The sigma is is known, sorry. So on the next slide, they're showing you a formula when the population standard deviation is now unknown or is not known. The sigma is not known, okay? Then when it is not known, meaning you will be given a what? A sample standard deviation, which is the S, denoted by letter S. So meaning we're going to be forced to use this formula. And then this formula, it says X bar plus or minus the TV, okay? And then the T, it means that we are going to use the what? The critical value of T, which is the T table. The V, it simply means the degree of freedom. Or sometimes it might be the DF. DF is same as the degree of freedom. So in some of the tables, it is denoted by DF or it is denoted by the V. Okay. Um, yes. So then comma theta divided by 2, then multiply by what? By S, because in this case our population standard deviation is not known or it is unknown, meaning we are forced to use the S, which is the sample standard deviation, divided by N. Same applies to what we did on the previous slide when the population standard deviation is not known. And then our answer should also be in form of what? In form of the intervals. Ne? And then as I've already indicated that the V stands for, okay, the V stands for n minus 1, meaning you're going to take whatever will be given from your data or your statement. Let's say they're talking about the number of items, maybe 100 passengers, which will be your n. And then you're going to say 100 minus 1, okay? Then you'll get 99. Meaning when we're going to our table of the T table, we are going to look that side, I think is the first column. Let me, okay. Yeah, I think it's the first column on that table. It shows the V, or they can denote it as what? As GF. Okay. So if it is the V or DF, we are going to check that value corresponding to the value that you got in your answer. Ne? So meaning is gonna be what? It's gonna be 100 minus 1, you'll get 99. Okay, and then your theta divided by 2, meaning we have to calculate the theta divided by 2. Okay, so we will show you when we are going to do the examples. Now just understand the formulas, because these formulas are main, and if you don't understand which formula is used, tomorrow you'll do the mistakes. So this one is, it applies when the population standard deviation is not known or is unknown, meaning we are going to use the sample standard deviation. That's why it is denoted by the letter S. Okay, and then we're moving to the population proportion. With the population proportion, they will ask you to calculate the population proportion. The population proportion is calculated in this way. The P, which is the probability, plus or minus the Z, alpha divided by 2, then the square root of what? The square root of P minus 1 minus P, close brackets, divided by N. This one is straightforward, right? This is the formula when we're going to use, when we're going to calculate the population proportion. These things they will ask you in the statement. They will ask you to calculate, so it's your responsibility to know. Actually, before you start writing tomorrow, make sure that your formulas are all in place, you note them down, so that whenever they ask you something, you must make sure that your formulas are ready. Ne? So that is the formula to calculate the population proportion. Do I have questions so far before we can move further? Any question so far?
No.
Okay, seems like I don't have any question. Then I'm going to move to the sample proportion. This is the form. I said that this is the formula when we're going to use for calculating the population proportion. Then on the next formula, this one is the sample proportion. With the sample proportion, they said that the P is the same, is the sample proportion, and if the P is not given, meaning it's going to be calculated like this. If the P is not given, you're going to say P equals to the X divided by the N, not X bar. You must make sure that you don't confuse the two. This is not the X bar, but the X, meaning it's going to be X divided by N. Then this is how you're going to calculate the what? The sample proportion if the P is not given. Okay, and even here they're telling you that the X is the number of items, is the sample having the characteristic of the interest, and the N you already know that is the sample size. Okay, so this is just the number of items, not the X bar, which is the mean. So you must not confuse the two. Now we're moving to the standard error. The standard error of the sample mean, we're also having the standard error of the sample proportion. Okay, so with the sample standard error, we're also having the formulas that we're going to use, the two formulas that we are going to use. Guys, am I still audible? Because it says my connection is unstable.
Yes.
Okay.
Audible.
So with the standard error, we're having the standard error of the sample mean and also having the standard error of the sample proportion. So with the standard error of the mean, as I've already indicated that they will ask you, you must not worry about the statement, but at the end of the statement, they will ask you what to calculate. either the population proportion, either the standard error, either the marginal error. All you have to know is that which formulas are you going to apply. That's why I'm saying that before you start writing, make sure that your formulas are all put in place. You indicated them that this is the formula to calculate the mean when the standard deviation is unknown, the population proportion. So all the formulas should be put in place, okay? So they're saying that the standard error of the sample mean when the population standard deviation is now known, okay? When the population standard deviation is known. Actually, if you can check this formula, is not, it doesn't differ with that one of the Z, which includes the Z critical values. Can you see it? Because even in this case, we're going to use the same approach when the population standard deviation is now known, okay? The sigma is known. This is the sigma, right? So if the sigma is known, we're going to use this formula of the standard error of the sample mean, meaning they will ask you to calculate the standard error, okay? But all you have to check is that, am I given the population standard mean, or is the population standard, standard deviation, is it known or unknown now? So if it is known, meaning I'm gonna use this formula, okay? Secondly, when the population standard deviation is not known, meaning it will be the sample standard deviation, which is given, okay? That's why now we are going to denote it by S. So the difference is that here we're going to denote it by the sigma, because the sigma will be known, which is the population standard deviation. Here it will not be known, it will be unknown. So we're going to use the S, which stands for the sample standard deviation. Okay. Do I have any questions so far?
No.
Guys, do you have any question?
No.
No.
Because I don't want to leave anyone behind, because these are formulas. When is going to do the examples, we're just going to move. We're not going to come back to the formulas. So it's important to grab the formulas, right? Okay, now we're moving to the standard error of the sample proportion. Like, guys, you must always hear what the statement is saying, because the formulas might be confusing, or you might fail to answer the question because of the English that they use. So you should not be confused by the English that they use from in the statement. So here we're on the sample standard error of the mean. And then now we're going to move to the standard error of the proportion. These two are not the same things. Standard error of the sample mean, and also the sample, the standard error of the proportion, okay? So now we're moving to the one of the proportion. So this one is the, okay, the standard error of the sample proportion. When the population proportion is now known, do you see it? On the previous slide, we were talking about the population standard deviation, when it is known and when it is unknown. So now, because we introduced another concept of the sample proportion. This is the proportionality. Ne? So when the population proportion is known, meaning if it is now known, we are going to denote our formula using the word the pi. The pi denotes that the population proportion is known. But when we're using the p in our formula, meaning our population proportion is not known. So it's going to be sigma p, which is it is equals to, it stands for the population proportion, equals to the square root of sigma into brackets 1 minus the sigma, I mean the pi, ne? Divided by n, which is the number of the observed items. Then when the population proportion is not known, it is given by what? Sigma p, which is equals to the square root of p into 1 minus p, close brackets, then divide by what? Divide by the n. Okay, so I hope you understand, you see the difference between the two from our previous slide and whatever we are also doing now. Ne? Then the marginal error, I mean the margin of the error. The margin of the error is used to estimate the population mean, and it is also used to estimate the population proportion, whereas the standard error is used to estimate the sample mean, and also it used to estimate the sample proportion. But the marginal error is used to estimate the population. Here we're talking about the population, okay? In the standard error, we're talking about the sample, but in the marginal error, we're estimating the population mean and the population proportion. So you must be careful between the two, because they might also bring it in the multiple choice questions tomorrow in your test. So you must always bear that in mind. Okay, so in the margin error, they will also tell you, when they ask you to calculate the margin error, they will tell you calculate the margin error of this particular or of this certain problem. Ne? So the margin error will also use the same approach. When the population standard deviation is what is known, when it is known, we are going to use the z critical value, multiply by what? By hello guys, am I still audible? Because my connection was it says unstable. Am I still audible that side?
Yeah, you came
Hello?
back, you were gone.
Yeah? Guys?
Yeah, we lost you for a minute there, but then you came back, so now you're audible.
It says your internet connection is what? Is unstable. So it
Yeah, you
says
can
that
continue.
the population standard deviation is known, right? Sorry, is given by what? The z, which is the z critical values, then multiply by the what? By the theta divided by 2 into the sigma. Remember, the population standard deviation is known, eh? So meaning it's gonna be sigma divided by the square root of n. Then secondly, when the population standard deviation is not known, we're gonna use this formula, meaning we're going to check the t critical values, which is the T table, ne? Meaning is the TV. And I already told you what is the V stands for. It stands for the degree of freedom. It either the V or the DF. So the V and the DF, they explain the same thing. And they are equals to what? They are equals to n minus 1. Meaning we're going to take the n, then you subtract 1 with 1. Eh? Then you're going to your table and check corresponding with your what? With your theta divided by 2. Remember, you need to also calculate your theta divided by 2, okay? And then into brackets, we are having the S. The S is the standard deviation. I mean, the sample standard deviation, because now the population standard deviation is unknown. We could not use the sigma, okay? Because of the S, all right? And guys, there's something that you need to know. If the no, but we will check it in the example when we go to the examples. Lastly, guys, I hear something. Someone is talking that side. I cannot hear what he or she's talking.
Yeah, I was asking if are we given the alpha or do we calculate it as well?
The alpha, we are going to calculate it on our own because they will give you the confidence interval. Guys, the meeting will end in 10 minutes. So after it ended, I think, yeah, let me try to finish this slide so that when we rejoin again, Jimel will try to maybe go through. If the network is stable that side, he can also write because he's using a live board that side, so we can be able to write something so that we can see, for example, number one, because this is the last slide for the equations. Then after then it will be examples throughout, ne? So the sigma, the theta divided by 2, we are going to calculate it. They will tell you at what confidence interval you should calculate. You must set maybe 90%, 95, 99. Ne? So we're going to calculate our theta divided by 2 from what we are given. The margin of the error to estimate the population proportion. This is the formula when we're going to calculate the margin error of the population proportion. Remember, in our previous slide, we were using the margin error to estimate the population mean. So here we're going to estimate the population proportion. When the population proportion is known, it is given by what? It is given by this formula. When it is known, okay? Meaning is the Z alpha divided by 2, the square root of what? Of pi into brackets 1 minus pi divided by n. This is the formula that we are going to use when the population proportion is known. Ne? Then when the population proportion is not known, it is given by what? It is given by Z alpha divided by 2, the square root of what? The square root of p into 1 minus p, close brackets, then divided by n. So can you see the difference between the two? The margin error to estimate the population mean and also the margin error to estimate the population proportion. So these are the formulas that we are going to use throughout when, depending on the questions that they're gonna ask you when we're going to do the examples. Okay. So do you have any questions so far on the formulas? Because the session now will end, then after we will come back, meaning now is gonna be the time for the problems. Any questions so far? Jenny, did you understand that side? Because I've been
Yeah. Can I
in that
also
side
ask
where,
again?
yeah? Then
Hello.
what are you saying?
Um, I was asking about the pie. Are we given the pie or do we use our normal pie distribution?
Agree, they will tell you on the statement what is it that you are given or what is it that you are not given.
And I'm not.
When the population
Yeah.
proportion is known, this is what you are going to get. When the population proportion is known, and it will only apply when you are going to calculate the margin of the error.
Thank you.
And the same applies to the population proportion when it's not known,
Mm.
meaning we're going to use the P. So you must always make sure that you understand your statement or your problem depending on what you are given. So let me try, because
Yes.
I'm still having 5 minutes. Let us try to read this question. Maybe when you come back, you'll have a clue of what you are given on this statement. This is example number 1, right? Let's take it that maybe it's tomorrow. I mean today. Hey guys, give me 2 minutes. I need to charge my PC. Anytime you to switch off. Okay, I'm now back. I'm having 4 minutes remaining for the meeting. We're having 4 minutes remaining. So you should just use the very same link in the group, right? The first link. Example number 1 says, from a sample of 100 Cape Town car commuters, from a sample of 100 car already that statement is a keyword, ne? From a sample of what? Of 100 Cape Town car commuters. So you must underline the keywords always. Don't leave anything out from your statements. All right. So you must read the statement according to understanding. From a sample of 100 Cape Town car commuters, the mean to commute to work daily was what? Was found to be 35.8 minutes. So they also given us the mean, which is 35.8 minutes. They're saying that assume that the population standard deviation, I repeat, the population standard deviation, not the sample standard deviation, but the population standard deviation. Meaning this is what? This is the sigma, right? Yes. So automatically when they said that the population standard deviation, you know that which formula you're going to use. Which formula are you going to use? Okay, let me just try to read the whole statement. They assume that the population standard deviation is 11 minutes and that the commuting times are normally distributed. You must set a 90% confidence limit for the actual mean time taken by all the car commuters in Cape Town to travel, work daily. Ne? So I'm gonna give you a clue. From a sample of 100, automatically this is a sample of 100 people, I mean 100 Cape Town cars. So meaning this is our n, right? Automatically we're having our n. So we're having our n, which is 100. Here they also specified we're having a mean which is what? Is 35.8 minutes. Then we're having the population standard deviation. which is the sigma, not the S. The S is the sample standard deviation. You must listen to the statement correctly. This is the population standard deviation, meaning is our sigma, ne? And that the commuting times are normally set distributed. Set a 90%, okay? So they given you the percentage, meaning which we have to convert it into decimal. So you will know that the percentage is, the overall percentage is 100, right? So meaning we're going to say 90 divided by 100, which will give us what? It will give us 0.9. Now I'm giving you the hint on how are we going to get the what? The sigma, right? I mean the theta divided by 2, sorry, not the sigma. Theta divided by 2. The sigma is the population standard deviation, right? So you must set the 90% confidence limits for the actual mean time taken by all calcometers. So guys, here on my meeting it says less than 1 minute. So please go to the group and rejoin again. Yeah. So if it kicks you out anytime, then go to the group and rejoin.